That's where I want to focus my time. So signals-based testing, I think I coined the term. I'm not 100% sure. Hold on, I'm getting feedback from my, yeah, thanks. And I consider it using the information that comes from the product's diagnostic and operational signal to make testing insights, right? And so by this, in Office, I'm referring to the telemetry that Office emits when you run it. It's like if you load Word, Excel, PowerPoint, whatever, it's constantly sending tons of information back to Microsoft about what you clicked on, events that happened, bad things that happen, and stuff like that. And we use it for product planning, looking at usage patterns. But the product team also uses this a great deal to see, are there problems in market? Are there things that are happening that we want to fix and such as that? The deal, though, is that it was designed for a post-ship kind of thing, right? It's already deployed, already being used and stuff. And what I wanted to do was make it something we could use when we're testing, right? But to do that, I had to make some changes to Office. I actually did the code changes in Office to do it. Make it testing aware, make it actually know that it's being tested, right? So there's a thing that comes on every row of the metadata that says this is under test. It's also decorated with information that identifies which test is running and under what kind of test, and different kinds of layers. So we could not just say, oh, this is test data and this is different groups of users, but what kind of testing are we doing? And maybe even what specific test was this when this happened? Which allowed us to isolate all the signals coming out of a certain set of activity and workloads and stuff. So once you're using the signals already to look at what customers are doing and what they're experiencing, the question now is, how do we do it during the engineering? And the way that we do it during the engineering is to provide a workload that you apply against the app, right? You know, run the app, doing things with it, doing testing in different kinds of ways. And it's in that workload that you then collect a signal and analyze using the same approach and tools and mindset that you do for looking for problems the customers are having, right? You know, can you make it crash in a way the customers are making it crash? Can you find errors that the customers are gonna hit and say, ooh, fix those now before it goes out? So it's a way of moving the same kind of analysis earlier into a pre-release phase. It's a whole concept of signals-based testing. I didn't invent this. It's been practiced in different ways or whatever's. I think I put the words to it. I think I coined the term, but I'm not sure. It's too obvious. There was actually my presentation in 2017, something I called Is Your Automation Any Good?, where I talked about evaluating what is your automation doing using this signal, because you can get kind of a coverage signature of every test that way. And one of the things that I said then was this obnoxious slide, do we even need to write tests, right? But the notion was, like, if you're getting all this stuff coming back from users about what they do that describes coverage in the product, could you use machine learning, reinforcement learning, or whatever to train a tool to say, oh, I'll find my way around the product, right? And I thought, that sounds cool. Ironically enough, coincidentally enough, Jason Artman was in the same PNSQC session where he was talking about test.ai, which kind of sort of does the same thing, or did. He's shelved it since then. So it's an idea that actually is not unique. A lot of people were having at this time period and stuff like that. So I went back to Microsoft and I started working on it. And then in the same theme as not unique, another team started working on it with money, budget, and people. And in a couple of years, they way outpaced me. I threw away my thing and jumped on what they're doing. It was out of the Windows team. And I feel much more comfortable talking about it now because just an hour ago I checked and they actually finally have patents on it. So it's not as if it's secret anymore, completely what they're doing. So the way it worked, which I want to cover shortly, is you have a client-side agent that is capable of looking at the UI, capturing the state, picking some action to do, click bold, open the file menu, switch tabs, whatever, and then looking at the new UI state, right? So state, action, state. Upload that to my server, right? And then do it again. Upload that to my server, whatever. The server collects this from thousands of these agents and builds a graph of all these state action state transitions, right? And this graph describes ways of getting through the app. Right? So the next thing that we do is we train the army. This goes back to the signals thing on the first tab. We're watching the signals coming out of this activity. And we're looking in those signals for things that we want to reward the agents for finding. You just clicked the bold button. You just went into print merge. You just inserted a drawing and things like that. We note the machine, the time, and the reward name, and send it to the service that's collecting these models. Every night, a process runs that creates an AI model that predicts sequences to generate that reward, right? Then, what do you mean by evaluated?
You get a reward for?
Oh, so I decided what. In this case, I was looking for clicking a control in Word, buttons, menus, scroll bars, anything that was a user interface item in Word, Office, Excel, PowerPoint. There were events that were associated with those. So you click this, you click that, you dragged this, you opened that, and things like that.
Particular priority for unappropriate or likely control?
Correct.
Okay.
It just happened. It just happened. And there's a whole thing about weighting the distributions to bias it towards things and stuff like that that I'm going to skip because it takes too long to go into. The next thing that happens is they call it guided exploration, but the agents come up in a mode where instead of randomly exploring, they ask the server for something to do. And the server gives them sequences that it predicts will hit the rewards it was told about. And it tells the agent, I want you to do this. And it gives them the model. Here's the model of the app. Now, the sequence may not be start the app and do the thing. The sequence may be down inside some menu somewhere. So the agent uses the model and looks at the thing it's supposed to do, which is an action, and say, how can I, based on this graph of the app, get there? So it finds its way to the start state of the sequence and then attempts to execute the sequence. And when done, says, give me another one. And then it gets another one and does the same thing over and over and over. So by doing this, it's attempting to repeat the rewards that it was given before. Okay, that's the process of getting the AI army, robot army, the guys that wrote this, they called it a robot army, to learn how to get through an app and make things happen that you told it, I want to see you do it again, based on a little bit of ML training. And it's ML training, specifically, they were like doing TF-IDF and picking the ones with the highest value and saying that's the one I want. That one was a very, not actually that sophisticated a training model. The things that got patented now are on reinforcement learning, which is kind of cool. I never got to play with that one before I left, but this is the basics of it, right? Now, here's the thing with this, and Michael, your question about, based on what and stuff like that. There's not a lot of expectation on what they're supposed to hit. There's not a lot of checking. I'm not saying there's nothing in here that tells the app you got to the wrong state, the wrong thing happened. It's not like pass-fail automation, right? You sort of are ceding some degree of control, and not sort of. You are relying on ceding some degree of control, because what I'm getting out of this is the tendency for this kind of training to go and do a lot at scale that I might not have anticipated telling it to do, okay? I am not relying on the ability to tell it, look for this thing, like, enter this formula into Excel and this plus this divided by that equals this answer. I'm not looking for that. It's not your typical scenario check pass. I used to use the language, I'm exercising the app. I'm making it move. I'm making it do things. And what we're doing while that is happening is watching the signal. okay, for problems. And one of the things with this approach is that unlike like experiential testing or exploration, where you're relying on kind of a human intuition for, I'll know it when I see it bad, right? Instead, you go for, you know what, I'm going to go for obvious. It's stuff that if it's in the signal, we always call it bad, you know, or it's worth us thinking about, is it bad? So top of the list, because we have a very, very sophisticated system at Microsoft that the whole world uses, honestly, for detecting crashes in apps. Those crashes are part of our telemetry signal. I can totally correlate with the session and everything that happened prior. Crashes are also always considered something that wasn't supposed to happen. So we went for the low-hanging fruit. It was easy to talk about. There's other kinds of explicit errors in the signal where a developer said, error, log it, right? And so that was in there. That was harder, and I'll talk a little bit why. We did some stuff with the performance team. The performance team in Office looks for, you know, where the 95th percentile on key actions are going from build to build to build. And we looked at that. That was working out. But to do this, we had to patent new technology for even analyzing the behaviors and stuff to correlate things. And we had to use some machine learning just to help us even know, do we care about some of these failures? So I'll talk a little bit about some of that. But the key thing is like one of the things I was leveraging is the team already knew how to look at telemetry signal and say the customers are having bad things happen. So now we're saying the bots are having a bad thing happen, right? Which, you know, should just work, but it's actually not as easy as it sounds. Okay. Oh, thank you. Sorry. I'm sorry. You know the thing, Michael, when I'm talking, I can't do anything complicated. Oh, there, I'm sorry. I'm sorry, you do. So one of the things, so this was being used on Windows, and they were using it to cover their like Calc and Paint and all the on-box Windows apps. And they actually had really good religion on if you find a bad thing in there, fix it, find a bad thing in there. Office wasn't used to this tool and things like that. But the other thing with Office, each of the Office applications, if you count the distinct number of controls that a user can manipulate, they all, for each of the apps, run in the neighborhood of 10,000. By the time you add them up inside the code, right? And so imagine trying to randomly, stochastically kind of browse around and try to hit all of those. I was able to demonstrate, you know, up to my skip level that I could hit about 70% coverage. That's what got me permission to say, let's build a team to help do more of this, was that I could do it. But it took weeks for these thousands of machines to get that broad, okay? And it was hard as hell because some controls like aren't right there. Some controls only expose after you go into certain functionality. It's only on this dialog, or it's only there if you click a picture and then this menu pops up and things like that. Data and contextual situations, and then testability issues inside of the Office apps. It's almost identical to the problem you get with web pages. You've got controls that are ambiguously identifiable by the signature in the API to get to them. And so now you've got to have this conversation about, can we put IDs in these things to make them easier to spot? And the answer was, if you want to. And I said, sure, I will. And it is, as hard as it might be for some web pages, the difficulty of doing that in Office is like crazy hard. But I actually put in like a month or two into adding automation IDs to help the coverage get better. The way we improved on some of this, so some of it was changing Office to have better markup on its UI, but there was a lot of tuning the configuration to make it, you know, lean in certain ways. Putting data. So one of the tricks I would do is like, for the stuff that only triggers in data, I would make like a Word file or an Excel file or a Power file that had all sorts of objects in it. And then before the automation runs, I would log into the account that it was going to run under and copy those into their default folder so that agents could accidentally stumble across them in the training in the file open menu. And that indeed boosted the coverage. Suddenly a whole bunch of new commands would pop up. So, this kind of thing was leading it. And click here, right? Okay. How much? Okay. Are you ready for the fire hose? This kind of thing, I'll just give you a number. I'm not working there anymore. This thing found thousands of crashes, in the thousands, which you think would automatically get fixed, but that's going to overwhelm the dev team. They cannot handle fixing that many. The other problem is that the number of distinct crash ideas inside the office space is in the mid 6 digits. So, it's like, yeah, you're buying scale. Oh no, I don't know how to deal with scale, right? This is actually a big difficulty of any kind of thing like this. Please make it stop doing that. I've got a t-shirt I made called "Don't Give a Monkey a Gun," which is almost like this. All of these groups contacted us. So the office feedback group, the little thing on top that says search for help and stuff. All of these asked us, what the hell is this? We traced it back. It's one of your machines. What does this do? And said, oh yeah, it's auto learning how to do it. And it found these things and started obsessing over the tools and using them, throwing off their action they were taking on things, their research and stuff. Had to show them how to filter it out of the data, but eventually tell the bots. OneNote has a great, awesome story that I want to tell, but my favorite one is the test control app that controls machines and is for returning machines to the system when it's done. The agent found him and killed them. So now these machines are in our automation system, and someone on the automation team who were just like my friends and buddies actually down the hall would have to manually turn them back in. So that's cool. These kinds of bugs are by nature intermittent. That's why they're out there. That's why they escaped and stuff like that. You're going after some of the hardest to find bugs this way and hardest to repro, okay? And you know what? I don't even need to tell the room about crashes and how they're so hard because of time issues, data, and things like that. This made it really hard to investigate and stuff. Furthermore, the sequences were hard to kind of understand which one of these is really doing it. We actually built a patented technology based on gene comparison stuff and diffing of sequences to say, we think these are the ones that gave you the crash, which that was fun to make, actually. Definition of failure is always clear. Just because a dev has been for decades saying log a failure doesn't mean they actually mean the product's having a problem that the user is experiencing. Sometimes it means, oh, here's a thing that our code automatically mitigates, like network error, tries again, everything's fine. Sometimes it's just, well, it's not a bad thing, but I wanted to know about it, blah, 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 blah. You get this really fuzzy state on what error means to a dev if you have not been taking action on every single one as a process. This is actually a social problem. It's a process problem. And the negotiation we started up with was with the release product team over them wanting actually a more distinct signal. Understanding what the agent did is difficult because it's doing a lot of sequences that are hard for a person to process and look at, and also because the language of describing what a UI is in the accessibility API is not the way the developers think about it and hard to read. So that's my funny attempt to do a slide fast. Replay by nature is uncertain. Okay, first off, remember the thing I said at the beginning. It finds where to start the sequence by its notion of the model. Anywhere it's at, like either to start up of where it's at now, it goes and finds its way there. It doesn't start from the same state every time by nature. There's another trick that it has, which was feature to keep the monkeys from falling into traps they can't get out of. It's like if it wants to do a certain thing next and that is not in the state, it says, given the state I am in, how can I get to the action I want? So it's got this find myself out of my trap logic that ruins replay. It's like, every time you make a thing better, you're trading, right? And so it makes it harder, but it also makes it really good at getting around and making the app do things, right? So you optimize for one and you Yeah, and there were bugs in the agent that made replay bad as well too. Prioritizing the failures is difficult. This one's crazy. You would think, oh, the app crashed, right? But with the numbers I gave you, right, and with a user base, I one time counted unique user IDs in Office, and I got up to 1 billion. Okay, now I don't think that's really 1 billion people. There's other reasons why that would be, but it's easy to believe hundreds of millions, okay? Trying to pick something that maybe your bot hit it before anybody ever saw it because that build's not out, and saying this one is going to be bad, you need to fix it, is a really hard case to make when they've got that kind of a pile coming back at them already. So one of the things we did is some of these we'd say, okay, are users hitting it already? What's the rate? That was an easy case to make, right? Like, this is over your normal threshold to fix. We think we have a repro for you. It's happening in lab now. Then I got contacts from product teams saying, we've been chasing this forever. You've got a machine hitting it over and over. What are you doing? Right? So that one actually self-fed a little bit too. So that was cool. Office has a whole data team that does anomaly detection to help them prioritize rising failures in production. And to some degree, the anomaly detection engine helped us make a case for bugs. So that was cool. And then I was experimenting with this and had a proof of concept going that I could take the signature of the bug in terms of call stack, break it down, look at the signature of things that failed in production, and whether or not those were over threshold, and then predict, is this bug going to rise, you know, when that build gets out? And I found that actually that prediction was pretty good, right? And so I could go from thousands down to here's 10 that I think are a good candidate for you to look at, things like that. How about after the in the QA section? I'll go on it. People, oh God, Jesus Christ. Okay, so the dev manager who built the tool, he got this thrown at him. I got this thrown at me by my skip level. People are writing fewer scenario tests. Let's use this instead. We hire all these vendors. I want to get rid of the vendors and use this instead. And I had to come back at him and say, this does not check your functionality. This does not say, you know, opening a file doesn't show the file correctly. It doesn't do any of that. And that's what the scripted tests you wrote do. That's what the vendors are looking for. You can't, this complements that with something they weren't going to do, but it in no way replaces. And I had to have this conversation over and over with this guy. And he had the dev manager on the tool that was working this, had to have this conversation over and over with. And, you know, I mean, you can kind of read between the lines on sort of the political pressures on my skip level for this one. He's like, you know, I want to justify costs, I want to save money, and blah, 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 blah. And that's, what's that? Yeah. Get rid of the vendors, right? And it's like, oh, great. Final stuff. So I just put up my website for and my book and things like that. Where I talk about some things. So the first question I want to hit is about the predictive model for the thing. So every time you get a crash, you get a call stack, right? You know, here's the methods within, bump, right? And what I did was I took treated the method signature inside each row of the call stack as a feature, right? And built a it was a binary classifier. And I don't remember, I mean, it's like a lot of things you say is which is linear regression working or is a neural network working, whichever one gave the best predictions. And I would input, I would train it based on crashes that had escaped and whether or not they were over the fixed threshold for the team, which was, you know, 1 part per million, right? You know, 1 crash per million sessions. And, you know, a lot of the teams would say, let's fix it. That's the number several teams were using. And so I said, okay, if it's over, it's, you know, and if it's under, it's 0. And that gave a predictive model that said, if you are hitting certain groups of modules together, then it's likely that it's going to be a popular crash, right? It's likely it's going to go over the 1 part per million thing, which means it's likely the product team will fix it, right? And I tried saying now for the crashes that the agents hit that haven't shown up in production yet, what do you predict? And then if I just go back in time and look at that data, pre and post going out, saying which ones actually got out and crossed the threshold. And I also biased towards avoiding false positive, which meant I tolerated a high amount of false negative in it. In other words, I'm not trying to catch them all. I'm trying to catch the ones that I'm very certain you would fix, even knowing that there's a bunch that you probably would have fixed as well that I'm not telling you about, because really what I was optimizing towards was reducing the amount of stuff you have to look at, because I'm going from thousands to a list you can look at, right? And actually that's the mood the product team was in, right? It's like, don't tell us about 100 of these, tell us about 30, or 12 or something like that, that's a whole nother concept in its own, right? It's like, when I chose this bias preference in the model performance, I was saying I am optimizing towards avoiding false positives, because I knew it was about maintaining the social relationship between me and the product teams. Like if I come at them, you have to fix all of these, and throw a pile on them, I've lost a conversation. They've got too much to do, right? So does that story make sense, or is there other questions about that? Yeah. So now the reason this presentation, I wanted to focus on the challenges, is because it's all about when you change the way you're testing and you change what you're looking for, you change the nature of what's hard and what's easy and what you have to do, right? And there's several kinds of the AI testing approaches that are out there, which I feel are somewhat similar. Now, not all of them. A lot of them actually take a very different direction, but some of them really are in this kind of, it's going to do a bunch of stuff that it figures out for you, and you just let it go and run, and its volume is going to produce a lot of stuff for you you'd never hit. And it's like, that's great, that's fine. We've done that kind of thing before. But if you do that, you're going to probably want to confront a list of things very similar to what I had to confront, right? It's like, you don't quite know what it did. Okay, that's going to confuse people. You're going to get a lot of things reported. You've got to deal with filtering the noise, right? And how you might have to even employ some machine learning and AI or other kinds of things to even help you filter it down and stuff like that. So that's why I wanted to lean on the challenges for this one. Yeah, John.
Get a better sense of signal. Like, so I'm using Microsoft Word, getting crashes.
Yeah.
It says send to Microsoft. They say yes, or default, it always does. So you get the static.
Yeah.
Crash. But what else do you get? The fact that I was what documenting.
So yeah. An ungodly long stream. So in any given session of, let's say, several minutes, there will probably be hundreds and thousands of individual data points, from just heartbeat signal, but here's when the app booted, here's when this display screen was up, here's when you clicked every single control in the app, here's when you were typing, here's how fast the typing speed was going while you were doing it. It does not tell me what document you opened. It never tells us about content. It's not in the signal. We do not know, because we don't want to avoid the problems. I'm sorry, we didn't. 32 years, you still say we in the present tense when you're not there anymore. It's in your core when you're somewhere that long. So there's a lot it doesn't know, but there is this huge volume of data that's in there. It actually sends quite a lot. Yeah.
So you're using machine learning to get it to start in a different place and then figure its way to.
So the machine learning part, by the time I was using it, was to create predictive models of, we think this sequence of actions will get you to this reward state. Getting its way through the model when given there was using traversal algorithms that are probably more mundane. The guy that wrote it actually went to school with my kids and lived across the street from me. That's you feel old. That's how, I'd have to ask Timothy about it, and say, so exactly how does it find from place to place? But it's traveling salesman, graph traversal models, Dijkstra's models and things like that. It's conventional stuff, just graphing stuff. So, other questions?
Any questions from folks on Zoom?
Quiet. Afternoon session, man. Yeah, I could see it, the eyelids. You go ahead.
If you were gonna join some new company with what would like let's say a small organization that like what would be the initial steps that you might to try to like sort of
so yeah, I will be honest about this work. This work is, I'm incredibly grateful to the managers that I was working on and working with at that time, because I did this because I wanted to, and they let me. And they were like, well, that sounds interesting. Maybe it'll be good. Go ahead and play with it. And like that whole 70% coverage thing was like, I was at this inflection point where it's like, Wayne, we got to know there's something in this. Prove that this thing can even cover, right? Or you're just going to have to do something else, right? And then after I got that, then they actually built a team up in Vancouver, BC to help with some of the operationalization of it. But the deal was I was working on this because I was engaging in a lot of tool for tool's sake curiosity, right? Because sometimes you do that, and Microsoft differentiates on innovation. They have a little bit of time to to spend on things like this, but I wouldn't take this dive probably in a startup, because there's a lot to build here. If someone had a solution that I might adopt it. The thing that I would push a company to do is the putting signal in product. That I believe is, and never mind for testing, that's for business intelligence. I mean, it wasn't put into Office to test with. It was put into Office to make business decisions, right? And then, the test team and the dev team are like, let's leverage it for stuff. The product teams in Office, the developers in Office watch that signal like a hawk. Like, I just released something, what's it doing, and stuff like that. So I would say, get your product signal for business and engineering reasons in there, testing, exploit it. That's I think is far more valuable than this particular activity, given where like a lot of teams would be. If this was commoditized because I mean, like the patents just got published recently and stuff like this. It's not a commodity behavior to be able to do this. If it was commoditized, then I might have a different story, but this is actually quite expensive to start and do. So good question though. I mean, it's like, other question. I totally relate to this time of day, man. I'm like, okay, that's, yeah. Okay, great.
Yeah, thank you very much.